Hello, this is a supplementary advanced math lesson covering lesson 58A in your textbook, the distance from a point to a line. And I'm going to be working off of the example on 382 in the textbook. So if you want to open up your books to that page to follow along, you can do that. Go ahead and pause the video and find your place. Okay, so really, I didn't really want to have to go over the math too much in this problem. It's pretty simple, and you all have proved in previous homeworks that you're pretty good at that math. I just want to explain the procedure a little bit more, just so sometimes it's kind of easy to get lost in a problem. Why are we going through these particular steps to get the answer? And so this lesson is meant to kind of explain those steps and keep the end game in mind, the big picture. So what are we wanting to do in that example? They're saying find the distance between a known point minus 3, 5 that I have up here and a known line. Y equals 1/2 x plus 1. Those are indicated in the orange there. Okay, and that's a common problem in many areas in science, math, technology, engineering. We want to know a distance, and we want to know it rather accurately. Okay, if we have a railroad line and we want to know how much track do we need to get to a new point, okay, we want to know that with a pretty good degree of accuracy. Now we could do it graphically, and maybe for a railroad line that would be fine. But if you have a printed circuit and you want to add another circuit off to a particular point, you might want to know, especially if you're laying it down in gold on a printed circuit board, what is the more accurate distance. Or if we're kind of working in the blind, if this is a mine shaft, okay, and we know there's a deposit over here at that particular point, okay, we want to know at what point do we want to start drilling a lateral, shaft to get there. And we want to know the distance to there too, because if we find if we've passed that distance drilling and we haven't hit the deposit, something has happened. Okay, so we need to stop and reevaluate our math. So sometimes we want a more accurate determination of distance than just through graphical means. Okay, so the steps I've outlined here are a 4-step procedure, and so simply what we're going to do, number one, we're going to determine the equation of the line perpendicular to our known line that I've indicated in the dashed white line there, and we have done that all the way from way back in lesson 10 in the textbook. So if you're a little weak on that, go back to lesson 10 and review that. Okay, once we determine the equation of that line, okay, we remember a set of equations, okay, will have common solutions. Okay, so once we determine the equation of that perpendicular line, we're going to put that line, the equation of the new line, I'm just going to put y here right now, okay, into a set of equations, because we know then this point xy is where they're going to intersect. I've indicated xy because we don't know the exact value, okay? But if we put the equation of the line and the equation of the perpendicular line into a set, okay, the solution for x and y will hold true for both lines. And where will that be? It is where they intersect. Okay, so that will give us the value of x and y using substitution, and that's a tool we've used all the way back to Algebra 1. Okay, third, then, we're going to actually determine the distance from our known point to the new point that we've derived through the use of the distance formula. Okay, and really, it's nothing other than the Pythagorean theorem, because what we have done, we've established a triangle here that I've kind of indicated in that red color. We'll know if that red color shows up well on the video or not. Okay, but it gives us a change in the y coordinates and a change in the x. We're going to put it in to our distance formula, which goes back to lesson 35. If you need to brush up there, go to lesson 35. Okay, then fourthly, we get into the last step, calculator discipline. So just because there's so many steps and we're doing a lot of different tools, they don't want to get you bogged down in the fact, because a lot of times in this distance formula we're going to have fractions, okay? We don't want to make it a really big exercise in how you can take square roots of fractions and come up with a real exact answer. We want a practical answer, okay? How many feet are we going to drill perpendicular to hit that ore deposit? Okay, we don't need to be exact, but we do need a practical answer. Okay, so let's look at the example there, and I've got it drawn here. The first step, we're going to find that equation of the line, and of course the two things you do, okay, with the known equation, you take the slope, you take the inverse of it, and you apply the negative of that. The negative inverse of the slope will be the slope of the line perpendicular to that. Then you take the coordinates from our known point, okay? So according to there, our line will be the minus reciprocal. The general form of our line will be this. So we take the known coordinate, minus 3, 5, we plug it in for x and y to determine b, okay? And in the book, b becomes minus 1, okay? So the equation of our line, perpendicular to our known line, the equation of the dotted line becomes this in the book. Again, I'm not going through all the steps in math, just doing it real quick, okay? So that is our equation. Then, that is the equation we put in to our set of equations, okay? And then we use substitution, okay? We take this value of y here and we substitute it into the first equation for y to solve for y. And then once we solve for y, we plug y back into one of these either one equations, and we solve for x. So not going to do the math. In the book, they have x coming to be minus 4/5 and y is 3/5. Okay? And then what do we do there? Okay? We use our distance formula. Okay? And again, it's the change in the x direction squared plus the change in the y direction. And we're going to use our points, minus 3, 5. Our new point that we determined was minus 4/5 and 3/5. Okay? So the important thing to keep track of, okay, what we declare one of them as the initial and one of them as the final. Okay? And it doesn't matter which way, but what matters is whatever point we call the initial, we use the x and the y component of the coordinate of that for the initial one. Okay, in the book, I have an I up here. They used this point as the initial point. They used this point here where it intersects as the final point. I have an F there. Okay, so initial point is going to be minus 3 for x and 5 for y. It's going to be minus 4/5 for x and 3/5 for y. Okay, so just keep that discipline. And so what they were saying there too, so we're not going to use again, for simplicity's sake, we're not going to use those fractions underneath the square root symbol. We're going to use decimal equivalents. Okay, so our decimal equivalents are going to be minus 0.8 and 0.6 in place of the fractional coordinates there. Okay, and so when we do that, then the next step, calculator discipline, and I'm going to recommend you go through your calculator. Each one is different, okay, and plug that in. So what does that mean? So to determine the distance, for me, it was going to be the square root of minus 3 minus a minus 0.8 squared plus a 5 minus a 0.6 squared. Okay? And so, oops, let me go ahead and shift this down a little bit there so you can see that bottom part. Sorry about that. And so when I go through and use my calculator here, when I enter the square root function on the calculator, it gives me a small square root symbol up front and a parentheses. Okay, now for my calculator, this one here, the parentheses includes everything underneath the square root symbol. So for me to do this operation, I have to put in another set of parentheses, okay, and then put in that delta x expression, all of those numbers, close off the parenthesis, I put the caret symbol for the power, and then 2. Okay, then I add, I put in another parenthesis. I put in that expression for delta y, close it off, another caret symbol, raising it to the second power. Here, okay, and then I put in another closed parenthesis, which closes off my original one here for the square root. Okay, and then I hit the equal sign. And for my calculator, that's what I needed to do to come up with the answer in the book. So go ahead and practice that on your calculator. What is the method that you have to do to get it to come out right? It might take a couple tries, but figure out how your calculator works. Figure out how you can put the distance formula into your calculator underneath the square root symbol, okay, and have it come out to the book answer. So I hope that helps. 4 steps. We've done them all before. We're just combining them now into a final problem. And again, we're not wanting an exact answer. Once we get to this step, underneath the square root symbol, change any fractions to a decimal and solve for an actual decimal number. Okay, so I hope that helps. Shoot an email or a text message with any questions. So long for now.